Hey everybody, we're going to take a minute and go through these notes on significant digits, also called sig figs. Sig figs you probably learned about in chemistry. They are all about how to represent a measurement and how well you use a tool or how accurate or precise a tool is. So there's some rules for it and there's some reasons for it. So let's go through some of the things that are review first. When doing some calculations for measurements, keeping in mind significant digits, one of the rules requires you to count how many sig figs. So first easy thing is anything that's not a zero counts as significant. 1, 2, 3, 4, 5, 6, 7, 8, 9, they're easy to count. Zeros are the tough guys. Okay, here's some examples. Final zeros to the right of a decimal count, okay? This is a 0, it is to the right of the decimal, and it is final, meaning it's at the far right. That counts. That means there are 3 sig figs here. The 2 and the 3 are non-zeros, and this is a 0. All right, here's a non-example. This 0 is to the left of the decimal. These are to the right of the decimal, but they are not final. They are not to the end, so they do not count. So this is only 1 sig fig. Now, 2.500. 2 and 5 are significant. 0, 0 are final zeros to the right of the decimal. So this particular number has 4 sig figs. So let's talk about why somebody would put those zeros there. If you have a caliper, it's a measuring tool, it will allow you to measure to the thousandths place. So that means you can say something is exactly that. You wouldn't put those zeros there unless you had a tool that could do that. Okay, and then I have the in-betweener rule. Okay, final zeros to the right, and then I call it the in-betweener. So 1057, no decimals, that 0 is in between, 4 sig figs. 2.309, that 0 is in between, 4 sig figs. Don't change a number that's in scientific notation, leave it alone. Okay, just look at the 2.06, that 0 is in between, there are 3 sig figs. This number here, whatever measurement this is that somebody had, they had some tool that could do this. These zeros are not only, they are to the right of the decimal, they are not final, but they are in between. So 1, 2, 3, 4, 5, 6 sig figs. All right, let's do a few practice ones. And again, these are for measurements, these aren't for just general numbers. Okay, 1.306. Well, the 1 is good, the 3 is good, the 6 is good. This is an in-betweener, that is 4 sig figs. 1200.89. The zeros are in between, so they count. So 1, 2, 3, 4, 5, 6 sig figs. All right, a little tricky one. This 0 is to the left of the decimal. Nope. These zeros are to the right of the decimal, but they are not at the end or final, so they do not count. The 6 and 7 count, and this 0, because it is to the right of the decimal and final. So 3 sig figs. All right, next one. 2.305 times 10 to the 5th. Again, don't write it out, just leave it as given. This 0 is in between 4 sig figs. All right, what's 1,000.0? 1, 2, 3, 4, 5. Well, we know the 1 counts. These zeros are to the left of the decimal, but this 0 is to the right, and it is final. This now counts as a significant digit, and you might as well call it a 6, 7, or an 8, or 1. It now becomes counted as a digit, and then these become in-betweeners. So it is 5 sig figs. Okay, multiplying and dividing. You need to use the counting for this. So these are the basic rules. You're going to see another video about how you can do this on your TI-84, make life simpler. But let's go through what the rules are. If you have some measurements, again, this isn't just for random numbers, this is for measurements. You would multiply and divide them as given, okay? You would look at all the measurements and decide which one was the least number of sig figs, and then your answer has to go to that number of sig figs. So here's your example. If you multiply 2.35, 1.3, and 4.221, you will get this number. So this one has 3 sig figs, this one has 2 sig figs, this one has 4. I didn't give you any zeros. So the least number is 2. So my answer can only have 2. So here's the first number, that's good. And then the next one I check, that's the last sig fig I can have, and I need to see, does it round? So 12.8 is definitely going to be 13. And again, because you're doing volume here, it's meters cubed. Okay. Sig figs when adding is a little bit different. It's not about counting at all. It's totally different. You still add and subtract as usual. Decide which is least precise. Least precise would be sort of like what was rounded off the most, like a whole number versus going to the hundreds. Okay, and then you round your answer to that precision value. Do not count sig figs. Underline that. Do not count sig figs. So, for example, if you add these measurements, okay, this is the tenths place, hundredths place, thousandths place. The least precise one was to the tenths place. So when you add those up, you get this number, 42.785. The least precise measurement was this one, and I'm not counting 3 sig figs because I was adding. I simply look at the precision it meant to the tenths place, so that means I round this number off to the tenths place, and again, proper rounding I check. So my final answer is 42.8. Just on a little side note, if I look at a ruler, it's a little bit crooked, I know, but you can follow with me. If this is 5, let's do centimeters, and this is 6 centimeters. If somebody tells me there's a measurement of 5 centimeters and they don't put any decimals, I'm going to back this up and put a 4 here. That means they rounded up to 5. That means that that measurement was somewhere from 4.5 to about 5.5, and that's my range of estimation. Now, if somebody gives me a measurement of 5.0, and they put that 0 on purpose, now mathematically those are still 5. There's no difference. Now I know that when I have tenths place, like this is 5.1, 5.2, 5.3, 5.4, this is not right, this is 5.5. That means I've now measured somewhere between those. It was either 4.9 and a little bit over, or it was almost 5.1. If someone tells me, and this would be the most you could get for a ruler, let's say 5.00 centimeters, now you're telling me it's on the money. So this is what we mean by sig figs and precision. How you write a measurement is telling me either how good your tool was or how well you estimated and recorded your measurement. All right, so take a look at the sig fig on your TI-84. Watch that video so you see how you can do this very easily. All right, thanks for watching.